Hi everyone, myself Debabrata Das. I secure All India rank 6 in JEST and 29th in JAM, IIT JAM. And now I am going to share my interview experience at IMSc Chennai, and I completed my BSc from Midnapur College Autonomous, and I my interview was on the day of 13th May to 2024. I have arrived on that day at 8 a.m. morning. Um, when I arrived there in the interview panel, there was three professors, two sir and one madam. They partially chill out my mind and uh, cool down my mind and and asked me your college and graduation, etc., and asked me my favorite topics, and then I told them my favorite topics are quantum mechanics, classical mechanics, mathematical physics, and thermodynamics. And they started with quantum mechanics. And first professor asked me that draw a one-dimensional potential wall of length L, and asked me about the energy and the wave functions, and draw the first three wave functions and their energy as well. I write I write the energy expression for this quantum mechanical system. It was n square pi square h cut square and over 2m L square, and wave function expression was root over of 2 by length of the potential wall into sine n pi x by L, as it is one dimensional. And they asked me uh, write down the first three wave function on the image of the wall. Then I started that it is for n is equal to 1, and the wave function was that's like. And as well, professor said me that the wave function should draw in same frame, means not a distinct frame, and it was the same overlapping with this first one. Then I write, and it is for n is equal to 2. And for the third one, I put the node, and the third one is it's like that. And then professor asked me, the what about the wave function in for n is equal to 7? What will be the wave function? Then I draw it in separate image. I told that for n is equal to 1, there was not any node in the image, and for n is equal to 2, there was one node, and for n is equal to 3, there was n minus 1, means two nodes, and for n is equal to 7, there was 6 node in the image. And I draw it. Then the panelist madam said that if you think that there was a perturbation, additional potential is arise in the side left right side corner about V naught, then what will be the effect on the wave function for n is equal to 7? Uh, they they are firstly they asked me for it there is any effect in the wave function. I said that some effect will occur in the wave function, and they said that what will be the effect of the wave function. Then I said that it, it is for without perturbation, without and for n is equal to 7, and the madam say that the energy of the particle is greater than the potential. Then every and the wave function would be sinusoidal for every region, and the propagation vector k is vary every point. For this part k is different, and for this part k also different, and for this part k will be, I note this as k1, and it is 2m e by h cut square, and in this region k I note it as k2 is 2m e minus v naught by h cut square. As e is greater than v naught, then k2 this term is decreasing, and so k1 is greater than k2. And they asked me the in the wave function what the change in the wavelength will be what types. uh, then I write it. I told them that in this region the wavelength should be larger than the rest of the part. Then they asked me to draw the wave function. Told that without when the potential, the perturbation is not there in the potential, the distribution of the node is uniformly distributed. But when the perturbation is present in the potential, the distribution of the and nodes are not uniform. There will be some shift toward the unperturbed region. uh, Something like here wavelength in this region is increasing, so the node number of the nodes is decreasing. I told that in this region only one node is present, but when the perturbation is acting on this potential, the number of the nodes is decreasing. So the number of the nodes, previously the number of the nodes is 1. After the perturbation, the number of the nodes is 0. क्योंकि because the number of the nodes is decreasing from 1 to 0, this node will vanish in this region. So the 6 node in this state, the total number of nodes remains same. It is 6, but in the perturbation region, it was not any node in this region. So the nodes are distributed like this. As like this. Then they satisfied with this answer, and they proceed to the next question from the classical mechanics. uh, the middle professor asked me, write down the Lagrangian they asked according to. I write L is equal to, they asked to write me as m x dot square is the kinetic part of the system, and they introduce a new type of potential as a x to the power 4. A is a positive constant. uh, they told me mm, uh, that the motion of the particle in this potential, uh, is it periodic or not, or such type of motion is called as. And firstly they told me to draw the potential. It is like parabola, not exact parabola, this looking like parabola. For parabola is like for parabola y varies x square, but it was x to the power 4. It's like that. They said that uh, assume the part assume the energy of the particle in this potential is E, then tell what type of the motion the particle occur. I told that for the classical region, at that point kinetic energy of the particle will be zero, and further region the particle will not move, and the motion of the particle is confined in that region. When the particle move toward the positive x direction, and after crossing that point, it will return return and move in the minus x direction, and at that point it also return, and it perform a periodic motion. Then the professor asked me, can you tell me or derive the time period of this motion of the particle? I tried. Firstly I cannot proceed this problem. Then they hint me, and I proceed like that. Uh, I firstly uh, write down the Hamiltonian of this system, and it is also the energy of the system. And the from this equation I write the px in the form of x, in the function of x, and ax to the power 4 into we know that momentum is m dx by dt, and I have to solve this integration to find the time period of the particle, and they asked me what will be the limit of the x, and I said that in this position, in the in this position, E will be is equal to x to the power 4, and x will be E by A to the power 1 by 4, and the limit will be minus E by A to the power 1 by 4, and I told that the integration is difficult to solve, and some computational method is required to solve this integration, and they said the okay, you can proceed to the next question. Is it about mathematical physics? They they told me that the what is the Fourier transform of a function. I write the Fourier transform in from the time domain to the complex frequency plane, frequency plane. It is the they tell me the condition of the Fourier transform like that the f of ft is lit. They give the condition that uh, they asked me what from that condition what property of the Fourier transform you can find. uh, I told them that here uh, the complex conjugate of the function is itself, then it is the real function. F of t is the real function, and they told me that then prove it, prove the prove something new property of the function. it is the constant term, so it will not change. And f star t, and if we complex conjugate of this term, then it will be iota omega t and dt. I told that, and I assume t star is equal to minus t and dt prime is equal to minus dt. So from this condition, and also the limit will change, then plus term will be the lower limit and the minus infinity will be the higher limit, and it I write the another form in the t prime, then I express it as a form of t. The limit will is that minus, upper limit will be the minus infinity f star t prime and a to the power iota omega t prime and dt prime. I get it, and 2 pi. Here I prove it that minus t and dt prime will be the minus dt. This minus term will change the limit formation. This minus is included in the limit part, minus infinity to infinity f star minus t is equal to minus e to the power minus iota omega t into dt, and I get, and as g star omega is equal to g omega, I write it as g omega, and compare with the first, I write that g omega is equal to 1 by root over of 2 pi minus infinity to infinity f of t e to the power minus iota omega t as dt. And from comparing these two definition, I can write minus t is equal to f of t. I told that the function will be uh, real and also even. Then they proceed to the next question from the thermodynamics. Madam, in the panel, get up and write in draw in the board as it is a insulated container is separated the volume is not equal like that. It is the volume is V and rest of the is 3V, and here the gas is filled in the small volume part, and asked that the separation will removed and the gas is expanded to the whole volume, and can you find the total entropy change of the system? I can write. I tell them I assumed that the gas is the ideal gas, and here it is the insulated system, so dq of the system is not come from the outside, or it is not go into the outside region, and I tell that them it is from the first law of thermodynamics, as dq is not changed from the outside region, as u is the function of only t for only ideal gas. T is not change. T is not change means dt 0. Okay. And PdV, as the gas is ideal gas, we can use the universal gas law PV समान nRT. From here I find the expression of the P as nRT by V. I put the value in the expression P by T in R by V, and partially they told me that the gas is 1 mole. R dV by V. I integrated it to find the change of the entropy. Here V is the, at first the volume is confined in the volume V, and after the expansion it can move in the full volume. It was total volume at first it was in the volume V, and after expansion it will be in total volume 4V. The change R ln V V to 4V. It was the entropy change of the system, and the total question of the four questions was asked in my IMSc Chennai interview, and the interview then completed, and after 20 days, in the 25th May, I got the mail of the selection. Thank you.